Hello everyone, we are working on the question number 6, computer skill lecture. We're going to focus on question number 6, where we're going to learn how to use the factor, finite population correction factor to determine if we have the infinite population or whether we need to actually apply this FPCF to our confidence interval calculation. Okay, let's look at the question together. Question number 6. A sample of 20 pages was taken without replacement from the yellow page, yelp.com, yellow page, yp.com, business directory that has 1,000 pages. Should the population be considered effectively infinite? And also, we want to calculate, I want to add on what is FPCF. Okay. So first, let's see if we can consider the population as infinite. To do that, we need to consider the rule of thumb, right? So the rule of thumb we learned from our PowerPoint, our lecture, is that if you believe your population is finite, let me go here. So what happened is your sample size has to be greater than 5% of the population. So that will be considered a finite. Otherwise, it will be considered as infinite. And again, we already do without replacement sampling. So therefore, let's just see what percentage of the sample population being sampled. Okay, let me go back to the formula. So first of all, we are able to know the value of n and n, right? So the sample we have is 20. So the small n equal to 20. And the population is equal to 1,000. So if that's the case, what is the value for n divided by capital N? So what is the percentage? So let's do it. 20 divided by 100 or 1,000. So that gives me 2%. Okay, so if it is 2%, given what we saw here, so since it's 2%, so that is less than 5%. So therefore, we do believe our population is to be effectively infinite. So if it's infinite, we don't need to use FPCF in our interval calculation. So we only need that if we are facing a finite population. So that's why at the beginning when I designed this question, I did not require you to calculate FPCF because I know the population actually is considered as effectively infinite. But since for the sake of calculation, learn how to calculate using the formula, let's still calculate the FPCF. But you need to know for this example, we don't need to use FPCF. Okay, we don't need to use it. But like I said, anyway, we still try to learn how to calculate use this example. First, let's look at the formula we're going to use. FPCF is equal to this formula. Let me just copy back to my Excel. Okay, so now we can calculate finite population correction factor. Okay, so this is equal to SQRT. Remember, it is square root, right? Square root, parentheses, and then don't forget another parentheses. That's why I want to practice with you because I want to make sure you know when you use Excel, it's always a good idea to have more parentheses than missing one. Because if without this initial parentheses, what happens is the calculation will become capital N and then minus small n divided by n minus 1. So they will treat small n divided by n minus 1 as the ratio versus capital N minus n first and then divided by n minus 1. So that parentheses become very important. You want to make sure you keep this parenthesis for your numerator. So after first parenthesis, you add the second parenthesis, and then choose the capital N minus the small n. Close the parentheses, and then divide it by, again, parentheses. Don't forget the denominator had 2 number here. You don't want to miss 1. So divide by capital N minus 1. Close the parentheses, and close parentheses. Now, then you can push enter. So if your sample for some reason it become considered as finite, this is the one I'm going to use. But again, I want to emphasize for this specific question, we don't need to use FPCF because our sample is less than 5% of your population. So therefore, we consider is effective infinite population. Okay, so that is the end of this video. And in our last video from chapter 8 of computer skill, we're going to look at how can we calculate a confidence interval, and then also to figure out what is the sample size we needed to do the estimation for the sample mean.